Hello, can you hear?
Yes, yes.
Okay, good evening. Hello, Prasad, can you see the screen?
Yes, yes.
Okay. Okay. Now we have to discuss today about the Inventor software. Okay. My name is Swadik. I am working as BA Grade 1 at BIMLABS Global. Okay. And our BIMLABS will be situated in Kerala, South State of India. Okay. And we are also the learning partner of Autodesk and the member of Green Building Council. Okay. The BIMLABS will be working on the major business areas like BIM training for students and corporates and implement the BIMs and support for corporates and organizations. And also giving also providing the BIM projects outsourcing and BIM placement services. And the other details we have, if you have any doubts, you will be inquiry for the details will be given below. And these are the certifications that we have to. Okay, now our company corporate office will be locating at Karakotam, Trivandrum, Kerala, and branch office at Statue, Trivandrum, and we have another branch office at Cochin, Ernakulam, also one virtual office at Dubai, and two franchises at Kollam and Calicut. Okay, the BIMLabs Global will be locating or will be based on three categories. That one will be finishing school. Okay, there will be implementing the BIM and CAD, CAM, CA courses. Okay, technology training with project internship and soft skill training. We will be providing the technology training with the project internship and soft skill training. Also, we will be giving BIM Studio for BIM CAD or BIM designs and documentation projects and implement BIM. Okay, the last stage will be bridge. There will be placement surfaces will be providing that stage of bridge in BIM and CAD. Tried to key AEC frames in South India and placing over. It's a old calculation. We in this month we will be placing 120 students in Mayan. Okay, and the BIMLabs Service Private Limited will be the partner of Autodesk Link and the IGBC Registered Institute. Okay, and also the capacity building partner of various AEC streams in South India. Okay, these are the specialties of our BIMLabs engineering services. Okay, also uh, the authorizing training center of Bentley and Autodesk authorized academic partner of our Autodesk and the member of Indian BIM Association or IGBC, Indian Green Building. Okay, now we have to go into our topic, that is Inventor. Okay, did you know about the software or hearing the about the software Inventor before?
No, sir.
Hello. Okay. Okay. Now I'll be giving a basic to Inventor. Do you hear the software AutoCAD before?
Yes, sir. Yes, sir.
Okay. What are the things we'll be doing at there? We'll be creating 2D drafting and 3D modeling. Yeah. AutoCAD is the best suited for industry professionals seeking to create 3D models and 2D drafting. Yeah. But the inventor, on the other hand, is specially for designers and engineers who create the parts, assemblies, and drawings with the manufacturing and production in mind. Okay, the inventor software will be using majorly using specially using for designers and engineers who create the parts. What parts? Mechanical parts, like their assemblies, the mechanical parts assemblies, their drawings, and they will manufacturing and production in mind. Okay, this is the difference between AutoCAD and Inventor. And why we will be using Inventor? Okay, I'll be saying that in our AutoCAD we will be creating 3D drawings. Okay, but there will be some differences. Yeah, the tools we have been using the AutoCAD will be 3D tools will be some difficulties. Yeah, likewise, in an Inventor software, we will be using more easily to work with the 3D softwares and extensive collections of powerful design tool. Okay, we have to be design design tools will be providing at the Inventor. That will be the extensive collections. Okay, and providing better graphics and intuitive interfaces and more file type options. Here we have so many file types options like RFA file, like we have to be import the drawing or the sketch or the 3D model into our Revit family file. That is the one advantage of our Inventor. The full package of engineers and designers. Okay. Also, the engineers and the mechanical engineers and mechanical designers will be using, and also using civil engineers and civil designers for the family creations also here, and they will be using the full package because it will be easy to work. Okay, then users to work faster. Okay, the users to work faster and more efficiently and accurately. That is a major one, more efficiently and more accurately. Okay, Inventor allows you can to incorporate specific technical detailing and manufacturing information right into your 3D project documentation. Like we have been creating different models, like parts of car. There will be so many parts like engine part, like that will be in engine part. There will be so many parts of piston like will be there. And in the last portion of our documentation, 3D project documentation, we have to be in specific the technical details and specific the technical details of our parts also. And also we have to convert and load the models into Revit family. Okay, these are the why we'll be using this Inventor. Okay, now we have to discuss the about the Inventor software. The Inventor software parent company is Auto Created Design Software. Okay, CAD software and developed by Autodesk. Okay, developed by Autodesk for what? For 3D mechanical modeling, stimulation, visualization, and documentation. Here in the Inventor software, we have to be do 3D mechanical modeling, stimulation, visualization, and documentation in one software. That is a specialty of our Inventor software. And the author of Inventor is Jacob Zane. Okay. Also, the software will be releasing in 1999. Okay. And where will be using this software? Professionals and qualified engineers, qualified inventors, mechanical designers, and knowledgeable hobbyists. Like they will be using these softwares for, or they will be working on this. Okay. Then what are the eligibilities to Okay, what are the eligibility to uh, for this studying this inventor software? That will be main. The minimum we have the 12th education and diploma in mechanical engineering, BTech in mechanical or automobile engineering, MTech in mechanical or automobile engineering. Also, IT students we have to be providing these courses. Okay, and the similar softwares like SolidWorks, Zero, Solid Edge, and Fusion, like that. The similar softwares we will have the inventor. Okay, now we have to start the software. First thing we'll be doing in our inventor, that will be sketching. There will be a 2D sketch we'll be also doing in our CAD, and the 2D sketching that will be doing similar like CAD, and we have to be different, that will be that creating 2D sketch after we will be creating 3D with the easy method and different tools to creating easy method. That is the difference. Okay, CAD documentation for our 2D sketches. Okay, and it's a sketch of or the sketch of our a component or a part that will be this. It's a front view and side view, top view. We have to be providing these views, and we have to be creating the 3D view also, and going to 3D modeling. We have to be created also a 2D sketch. Okay, and the finishing of our 2D sketch, we will be converting that 2D sketch into a 3D sketch. Like if I will be creating a sketch of net. Okay, then I'll be just doing a sketch of net. We have to be convert that sketch into a 3D. Okay, in a solid geometry. Okay, that is the major one. Okay, and we have also give the materials into that 3D modeling. Okay, and here before I will be giving you this front view, side view, and top view. That parts 3D will be here. That is this one. This is the 3D of that one. Okay, that 2D sketch also. And here we will be using extrude tool, revolve tools, you coil, emboss, rib, and holes we have to be providing into these sketches. Also, we have to creating easy, similar to AutoCAD. Okay, and it's a video to understanding that one. I just playing that one. Okay, here we part of a component or a part of our machine into our AutoCAD. There we are seeing that a CAD drawing will be copy and paste into our inventor. That is a easy method. That the another software we didn't do that one. Here the 2D of the a machine part that will be created in also in a AutoCAD. Okay, and that will be just selected and block, and then will be uh, convert or copy into and paste into our inventor also. Then they will be providing like this one. Just see that. Okay, that we have to be seeing that they will be creating that holes very easily. Okay, similar to our AutoCAD, that will be so easy to do that one. Okay, they will be putting a sketch of that one and mirroring that into that four portions, or paste into that four faces, and they will be just applying that extrude and give the hole into, or cutting that portion openly. In the last portion, they were saying that a AutoCAD drawing will be attached to our inventor and doing some changes to that created or created 3D model, and also doing some changes in our sketch in our AutoCAD. That will be similarly, that will be changes to that inventor also. These are the some useful to our one, and the next one is surface modeling. Okay, anyone know that about the surface modeling? Okay, the surface modeling means that a designing of zero thickness surface bodies. Okay, there will be a designing a zero thickness. Okay, that is a major thing. Okay, that is a main point. Zero thickness surface bodies. That is surface modeling. If we will be creating a metal sheet, or like a parts of our car bodies, like that will be creating this here. Okay, in surface modeling, and we have to be creating a surface of our bottles, and okay, we have to be providing a body with a zero thickness. That is surface modeling. Also, it will be done with our inventor. And sheet metal designing. Okay, we have to be creating the sheet metal designing, and it has some designing like a HVAC duct modeling. That will be a sheet metal design that we have to be providing at here. Okay, the thickness of the metal that we have to be providing at here, and also that is the another advantages of our inventor. Okay, they will be providing any surface modeling and designing like that one. And here we will be doing that one. Okay, we have to be creating a sketch of that sheet metal, and we have to be giving the extrude. Using that extrude, we have to be providing the sheet metal designs. And the next one, okay, after the creation of our surface modeling, 2D drawing, or 3D modeling, or the okay, after that we have to be render that one and animate that one and presentation. Okay, these three steps are next one. Okay, you can run the rendering command with no enhancements to the geometry you obtain directly from Autodesk Inventor parts and assemblies. That means that we have to be providing the materials to that parts. Okay, and we have to be providing the background lights, styles, and camera viewpoints, providing the visual intersects and sensor scales. What we have to see in that rendering time, and also the animation time we have to be also the uh okay also the animation time which components that will be working or that components what have to be done that with that how many times if I'll be explaining that a shaft will be rotating. Okay, we have to be saying that how much will be rotating in how much time. Okay, that we have to be providing into that animation. Okay, that will be done. And shafting movements we have to be providing that animation, making simple animation creating models we have to be providing until here. Okay, the last one is presentation. The presentation means that we have to be arranging that components in a group. Okay, and last time we will be presenting that time we have to be detailing that each and every parts or components that will be assembled. Okay, that time. Okay, a video to understanding that one. Here we will be seeing that one. That will be a group of arrangement or a assembly will be there. Yeah, that will be in the presentation time. It will be changing to separately. Yeah, we have to be seeing that it will be each and every parts will be going in separately. Okay, that is the useful in the preparation time or presentation time. Then we have to be seeing the separate and after exploding we have to be seeing the separate components or separate parts of that model or that that one. Okay. There they will be doing the mistake. That will be using a cloud. Okay. A cloud will be representing a mistake or a rechange that will be done in the portion of that type. Okay. That is using cloud. Okay, that is the 3D modeling and rendering and presentation. And now we have to go into the next level, stress analysis. Okay, after the finishing of our 3D modeling, we have to be analysis. Yeah, in our BIM, we have to be creating after anything. We will be analyzing each components and each parts. Yeah, there also in our that will be also in our inventor to analysis that one, that model or that part. Okay, here in the stress analysis, there are two types of stimulations. Okay, stimulations means that how much load it will be uh, loaded, that components or that will be loaded, that will be stimulation means that. And here will be two types of stimulation, and static analysis and two type of analysis. That one is analysis, static analysis and structural load conditions. Okay, the next one is model analysis evaluated natural frequency modes including rigid body movements. And there will be a movements with the body. Yeah, each body will be in moment. That time that will be load or the stimulation will be applied into that time. The body will be accept that one, or the body will be stronger to loading that one. We have to be checking that stress analysis in that portion. And also the stress analysis have a video. They will be saying the documentation button that will be in our last one. Okay. After the creating our documentation, we will be analyzing our machine or our part. We will be analyzing our part. It will be how much load will be loadable, or it will be how much stressable, or that will be analyzing at here. After the simulation, we have to be know the components or parts that will be not loadable, or that will be or supportable. We have to be changing easily. If an updation will be done in your starting, there will be changes automatically. Okay. Saying here, if we have to be seeing it here, we have to be seeing here, there will be a change will be doing at that portion. Okay, here they will be giving a change, and that will be automatically changed it to that 3D model. That's the major advance of our inventor. Yeah, here will be the understanding, there will be a problem that will be occurring there, and they will be just giving a cloud to recreate that one, and they will be just going to change the dimension or the equation. That's automatically will be changing your documentation also. Yeah, you have been seeing that one. Okay, it's automatically changed to that documents also. That is the major use of our inventor. Okay, the last one is final documentation. Okay, the final documentation means that after our completing the sketching and simulation and the modeling, we have to be document the 3D model also. Okay, also will be done the 2D documentation in the start one. That also will be done at here the last one, the final documentation. We have to be providing the 2D and 3D production documentation also. Okay, we will be just section the each and every parts of our machine and giving that section. That will be after the section we will be providing the sketches 2D into our documentation. Okay, that is the final stage of our documentation. And the inventor software will be majorly used or majorly placed in the department. Because around the PLM department also, that will be in our MEP, BIM in MEP. Okay, both of there will be using this inventor software. We have the qualifications for the told this course. Inventor course will be told the diploma degree in mechanical engineer or IT students also. We have been providing these courses, and the duration of our courses will be 3 months or 400 hours. Okay, then in our PLM department also the Fusion 360, Primavera, CAM, like that softwares will be in our PLM department. Also, there will be an analysis softwares will be given as diploma degree mechanical engineers students also, and providing the courses at a 3 month. Okay, in the final stage of our completing this course, we will be providing internship. These in the main areas we will focus in the main areas of our designing of components and designing for models, and we will be giving the internship based on 3D modeling of mechanical equipments and machineries like one. Okay, any question and answers? Hello, can you hear? Okay, if you have any inquiries, you will be just contact with the these numbers, or the I will be seeing that slide. Okay, just inquiries you will be not this mails, WhatsApp number, Facebook, Instagram pages, or web pages, or LinkedIn pages. You have to be inquiring that one. Also, I just giving a reference of our inventor software. Also, I will be just giving a reference of a mechanical drawing or a machinery drawing. I Okay, there's some designs like this one. I'll just opening and just give a reference how this will be useful to you. Okay, a mechanical student or a mechanical engineer or mechanical designers, they will be also using these softwares for their entire life. It should be advanced software. Will be also doing or working these softwares in our ISROs and airspaces. Like this, they will be using these softwares also. It's a scope full software also. Okay, few of them will be know the importance of the softwares also. Okay, this is a part of a engine that will be done. Okay, likewise, we have been doing these sketches like this one. Okay, that will be done. I'll be just giving an example how what things will be done in the inventor. This is a sample to understanding that one. Okay, I hope that you all of them have the understanding. Okay, thank you.